u equals 4x cubed minus 1. Okay, now what do I always have to do? I'm trying this out. We're wrong, we're wrong. We're right, we're right. What do we do next? Derivative. du equals 12x squared dx. So, I need, currently I have this, u, and then I can keep the 5, that's fine. I need to get rid of the x squared dx because those are not the right variables, correct? So what could I do to that formula over there? Yeah. Yeah. So I get 1 over 12 du can replace straight across x squared dx. So I still have the 5. I'm going to replace it with 1 over 12 du. So I technically have, if I want to rewrite this, 5 over 12. With a u on the bottom, what can you do? It's u to the one down here. Can I bring it up here so I don't have to do quotient rule? Anti-quotient, I don't even know what's going on. U to the negative 1 du. What can I do with the plain old coefficient if there's just one coefficient with a monomial? Yeah. I don't know what's going on. Move it in front. All right. So we get 5 over 12 u to the negative 1 du. And then we raise it to 1 power, and it becomes a 0. And then we think, girl, please, she told me when it becomes a 0 and I divide by 0, there's something up with this. Then yep. Lawn. That was my fault. Okay. So we get 5 over 12 ln absolute value of u. We have to do absolute value because when we plug in, it has to always come out as positive beside log. You can't have a negative. Plus c. Voila. Merci beaucoup. Okay, so these are still, let's put the u back. Can undo what I did. Let's see. Don't take the whole thing. Okay, 5 over 12 ln absolute value 4x cubed minus 1 plus c. Now box. Okay, so these are indefinite integrals, which means we don't have an actual value to fill in, correct? We can't use the fundamental theorem of calculus where you plug in the highest minus the lowest. 1 on the top minus 1 on the bottom. So we have another one for you to try. E to the x integral of e to the x over e to the x plus 4 dx. Try that one. So a good hint is if it's e to anything other than x, u is usually, not always, whatever the exponent is. If it's like a convoluted exponent on the e, like 4x squared plus 1, u is usually that. In this case, if it's just basic e's, I'm going to pick the ex plus e to the x plus 4 because I know the derivative of e to the x plus 4 is e to the x because the 4 goes away, right? And then I'll get, oh, that, right? It's like a little puzzle sometimes trying to figure out. Now, if you pick the wrong thing, you'll know because not all the x's go away. Try another thing, right? So I'm going to pick the bottom. U equals e to the x plus 4. Then I do the derivative of it. Du equals e to the x dx, which replaces the top. So I'm going to get, ooh, thanks for joining the party, integral symbol. Okay, so the bottom is a u, and then e to the x dx turns into a du, which I can write like that. Or I can write 1 over u du, or I can write as u to the negative 1 du. All of them are the same thing, okay? Most often people are better if they move this up. So they'll go u to the negative 1 du. And what's the antiderivative of u to the negative 1? Ln. So ln of absolute value of u plus c, which equals ln of absolute value of ex to the plus 4 plus c. All right. one more indefinite, and then we're moving to definite. So ones we're going to have to use the fundamental theorem of calculus, because they'll have numbers on the integral symbol. So you're going to actually find the area. So what we're doing right now is we're finding the general area under the curve, correct? I could plug in any x, any y, and I could get my, or any two x's, I can find the area under the curve. Again, the general, that's what the indefinite integral gets you. A definite integral asks for the area between two specific x values. That's the only difference. So you have to use the fundamental theorem of calculus. So, this one. X square root 4 plus x dx. So, u is often what's underneath the radical, so we take u equals 4 plus x, and so then I end up with something needs to be replaced, u needs to be replaced, correct? I do the derivative of this, and I get du equals 1 dx, correct? So then the dx replaces with du, and then, I don't know why I wrote it so high. It's a thing. Okay, du. And then we still have the x. Boo. Boo, 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 boo. So how can we replace the x? I gave you hints. Pardon, what?
Divide x of du over x equals
No. What can we do? Can rearrange that one. Yes? So we're going to get x equals u minus 4. So I'm going to replace this x with u minus 4. And then people are like, how is that any better? Well, we can get it back to a power rule, because this is u minus 4 times u to the half du, and then we can distribute. So we're going to get u to the what? U to the 1 times u to the half is u to the? Add exponents, right? So it would be 1.5 or 3 over 2 minus 4 u to the half du. Then I can just do a really beautiful reverse power rule with fractional exponents. So fun. If you're so happy you're here today, because you didn't think it could get better, but it did. Okay. Also, you don't have to watch the podcast from these days that you miss, because you're here. Sucks to be the other people. All right. So, what's the reverse when I add 3 halves? When I add 1 to 3 halves, is what I meant to say. What do I get? 5 halves, and then I divide by 5 halves, so I get 2/5. Minus 4, u, add 1 to 1/2, I get 3 halves, and then I divide by 3 halves, which is like multiplying by 2/3. Plus c. So I end up with 2/5, and they often write it back as a radical. So 4 plus x was u, so we'll get the square root of 4 plus x to the 5 minus 8 over 3 square root of 4 plus x cubed plus c. So we have to remember that we can rearrange that first u formula if we still need to get something else to replace, right? Because that first formula has a u in it as well. So sometimes that has to happen. Okay, definite integral. Means we have letters on it. And by letters I mean numbers. Whew, I need a break. Okay. This one is easier than the last one because the actual derivative of the u gets you the other stuff. So try this one out. Now, actually we're going to do it together because everyone does it wrong. Okay. They don't do the question wrong. You guys do the fundamental theorem of calculus setup wrong. Okay? So, how would we attempt this question? What would we make be u? 4 minus x squared, maybe? Try it out. So u equals 4 minus x squared, and then du equals 4 goes away, negative 2x dx. And I need to replace the x dx, so I go and multiply by negative a half, or divide by negative 2. So I get negative a half du equals x dx. Now this is where it goes badly. Not the indefinite part, it's the numbers on the integral that you guys screw up. These numbers, the 0 and 2, correlate to what variable? X, right? The 0 and 2 would get plugged in for x, would they not? Okay, that's good talk. Okay, now we're going to replace this with negative 1/2 square root of u du. So can I put 0 and 2 in that are actually responsible for x values? Any idea how I could replace those with u values that would correlate to the 0 and the 2? Look to the right. You have a u equals possibly over there? Do you have a u equals 4 minus x squared? Do we know what the x's are? One of them is 0 and one of them is 2. So I have to plug them in there to get the real u's that would go with it. Gotta stop touching the chair. All right. So you have to replace them where they are too. So if we take the 2 when we put it in there, even if it comes out smaller than the 0 one, the 2, whatever it is has to stay on the top and the other one has to stay on the bottom. Whatever you replace the u with. So if I go to the 2, I'm going to get u equals, we're getting x equals 2 for this one. U equals 4 minus 2 squared, which comes out as 0. So that 2 in u values is 0. Do you see how I have to put the u value there, not the x, because I don't have x's anymore? Does that make sense? Because that's where I lose people. They'll go and they'll leave 2, 0 the whole way through, plug back in the x, and put in the fundamental accounting principle of 2, 0. I'm like, they're like, but I get the right answer. I'm like, yes, but in the middle you're totally wrong because you have x values in for u's. Okay? And then we plug in x equals 0, which is the bottom one. 4 minus 0 squared, which is 4. You don't flip-flop them. They still say 0, 4, wherever they are. It doesn't matter if the bottom one's bigger. Okay? You try and do the antiderivative of that, and then we'll talk about how to do the definite integral of it. Go. We can do this 2 ways. I'm showing you the one with the u's because they can do it however they want, right? They could say u substitution, how am I subbing in? If we replace it with the u, we have to use 0, 4. We take the negative a half out. 4, 0, u to the half du. Okay? Then we do fundamental accounting principles. So we have negative a half. I raise that to the by 1. What am I going to get? U to the 3 halves. And then I'm going to divide by 3 halves, which is multiplying by 2/3 plus c. And now I go 4, 0. So I'm going to get negative 1/3 u to the 3 halves plus c, 0 to 4. Fundamental theorem of calculus says I have to plug in the top, then plug in the bottom, subtract them. Correct? That hasn't changed. So I'm going to get negative 1/3 0 to the 3 halves plus c minus negative 1/3 4 to the 3 halves plus c. We're going to do this without our calculator because this is a question that could be no calculator. 0 to anything is gone, right? So I'm going to be left with negative and negative 1/3. So that's 1/3. And then what does 3 halves, 4 to the 3 halves do? I have to take the square root of 4 and then cube it, correct? So the square root of 4 is 2, cubed is 8. So I get 8/3. Right? Now, how we could do this is technically we could just find the indefinite integral of the original, find out what it is, and then plug in 0, 2. Right? We could do it that way as well. We could do. Gotta stop touching the chair. I gotta move the chair. It's in my reach. can't type. All right. So you could technically just treat this original as if it doesn't have numbers on it, find the indefinite integral of that, and then use fundamental theorem of calculus 0, 2 and figure it out. Right? You could do that. They will show it this way, though. They'll substitute the u's. So that's what we're going to do. Okay. New question. That one's harder than that one. Okay. What are we on? E. Going to replace x squared plus 3. du equals 2x dx. I need to replace x dx, so I'm going to make it a half. So I get a half du. Come on, there we go. Equals x dx. All right. So we are going to have 1/2 over 1 plus u squared. 1 plus u squared. Nope. 1 over u squared. du. And then I can't just put the 0 and -2, correct? Those are x values. How do I get the y or the u values? So I get u equals 0 squared plus 3, which is 3. And then u equals -2 squared plus 3, which is 7. So I get 3 and 7. All right. So I get 1/2 out. Oh my goodness. All right. And then I get 7, 3. U to the -2 du. How do I do the antiderivative of u to the -2? Shh. Ahem. Antiderivative of u to the -2. Let's go. Pardon? Negative u to the, wow, that changed. -1 plus c from 7 to 3. So I get -1/2 3 to the -1 plus c minus -1/2 7 to the -1. What is something to the -1? Just 1 over, yeah, 1 over 3 plus 1/2 1 over 7. So I get -1 over 6 plus 1 over 14. What's 14 times 6? I don't want to use my brain cells. 28, 56, 84. All right. -14. Come on. Ugh. Plus 6 over 84. I need to restart my computer.